Hello folks, Blair here again with Curio Mechanics. In today's video, we're going to discuss some of the things I've learned in my journey with 3D printers through the years. Let me start by saying that this video will focus on the type of printer known as Filament Deposition Modeling, or FDM for short. This is probably the most common form of 3D printer. It works by a nozzle being moved around and the filament being squirted out to pile up and build the model. I also have used and own several types of resin printer that use ultraviolet light to cure a special fluid one layer at a time to build up a model. FDM is best suited to rapid prototyping and structural part creation. Resin modeling is best suited for things like figurines, where a high level of detail is required. In the industrial world, there are several other types that can print a variety of materials, including metal. In principle, an FDM printer is very similar to a CNC machine. CNC stands for Computer Numeric Control, and is essentially just a cutting head being moved to various coordinates by a digital control that is following a pre-programmed set of directions. The nozzle of an FDM printer is doing the same thing and even uses the same language under the hood to do so. The language is called G-code and dates back to at least the 50s, if not earlier, and can be found in an incredible array of industrial machines. The basis of G-code is simply move here, do this, move there, do that. It is normally written in plain text and requires an intermediary controller to translate the instructions into pulses to the stepper motor that do the actual movement. A stepper motor is simply a motor that moves in specific increments and can be trusted to have an extremely accurate position based on the electrical signal sent to it. The stepper motors are also the main sound you will hear when a 3D printer is running. It will create various tones based on how fast the motor is moving. The other dominant sound is the cooling fans that are running. Besides a fan in the power supply, there will also be a relatively powerful fan that blows directly on the extracted filament that will allow for faster hardening. This is used to speed the printing process so that each layer can be laid down faster. Like solder, the filament is heated to what's called its plastic zone, which is where it becomes a fluid but not boiled. Each type of filament has its own temperature range that is best, and even different manufacturers will recommend slightly different temperatures based on the exact composition of the material. The most common form of filament is called PLA, which is an acronym for a fairly long word describing the polymer it's made of. It is probably the most forgiving and requires less heat than most other types. It is fairly rigid, but has almost no flexibility, so it's not especially strong nor suited to high vibration environments. Another common type of filament is PETG, which is the same material plastic soda bottles are made from. There are several designs that actually allow you to recycle your empty soda bottles into usable filaments for printing. PETG requires more heat but offers greater strength and is slightly more resistant to vibration. The problem with using a higher temperature filament is that it is more prone to warping and distortion during the printing process. In more extreme cases, a printer can be put inside an enclosure that will help keep the printing area warmer to combat warping or printing failure. Unfortunately, failed prints are commonplace and become a part of the life of a 3D printer. Common causes are poor bed adhesion, poor filament condition, nozzle clogging, and even sometimes user error. Because each layer of filament requires a layer underneath of it for support, Once a print goes wrong, your print bed will probably end up looking like a plate of spaghetti, as the nozzle dispenses your favorite filament into the air and it falls randomly all over the place. I have actually ruined more than one printer by simply letting failed prints get out of hand. One of the most important parameters that you need to stay on top of is the first layer. The filament should be set down on the print bed in a way that sort of squishes it onto the bed without being so tight as to clog the nozzle. The squishing allows the filament to better adhere to the bed. If the model slips in any direction while printing, each layer above it will miss and wind up going into nothingness. In earlier printers, it was common to use tricks such as coating the print bed with glue stick or painter's tape to give a better grip. More recent materials for the print surface have allowed for a better grip and made most of these tricks unnecessary. The problem is partly that if you make a surface too grippy, you'll never get the model off it when it's finished. Scrapers are used to help release the model when it's done, as well as newer bed plates actually being magnetically attached and allowing you to take them off and flex to get the model to pop off more easily. More exotic materials like ABS, nylon, and even carbon fiber are even more sensitive to these issues, and experienced users have come up with all sorts of ways to get the best results. I have personally never tried these materials, as I simply don't want to push my luck even further than I already do. I've gone through at least a half a dozen FDM printers in my journey of learning, and have learned through Pavlovian teaching not to anger the printing spirits more than I need to. Let's talk for a bit about how to get the files ready for printing. The files are usually created in a computer-aided drafting, or CAD, program, then exported. The format I see the most often is the STL file extension. The exported files are then imported into a special type of software called a slicer. What this does is take the three-dimensional information and translate it into a series of layers that the printer will then create one at a time, working from the bottom up. The other thing a good slicer will do is be aware of areas that require some type of support to print. Because you can't just print randomly into thin air, certain openings and steep overhangs will need a sacrificial piece that starts at the print bed and goes up to wherever the filament needs to start in thin air. An example will be a drawer with a handle. While the drawer would follow a mostly straight line from the ground up, the handle would then project into open space for say an inch or two. Because there would be nothing underneath this handle to support that layer of filament, a support would be used. Once the model is done printing, the support would then be removed and discarded. Most home printers are designed to work with a single filament at a time per model, but fancier models allow several different types or colors of filament to be used in the same model automatically. Because of this, one thing that's evolved are support filaments that can dissolve in water or be more easily removed. Printers that can handle more than one filament automatically require a bit of extra hardware, actually quite a bit of extra hardware, and are consequently significantly more expensive. I have never used one personally, but maybe someday I'll be able to justify the expense. I have programmed a CNC machine that was capable of automatic tool changes, and the code was simple, but it requires more time and machine effort each time the tool is changed. So the ability to switch between, say, two colors might require 3 times longer. There is also more waste, as each time the printer changes colors, it must purge all of the previous color from the print head and nozzle when it switches. The other concept to touch on is the care and feeding of these machines. Because they are generally belt-driven, the belts can stretch over time and require retensioning. You will also want to periodically clean and lubricate all the rollers and slide surfaces. Dirt acts as an abrasive, and since most of the machines are capable of less than 1/10 of a millimeter accuracy, any physical deviations can lead to problems. Another common maintenance issue is nozzle replacement. As the filament is being dispensed through the nozzle, it is gradually sanding the opening and causing it to become larger and more irregular. At some point, it will have to be replaced. Brass is the most common nozzle material as it has the best heat and flow properties. I have used hardened steel nozzles and found that they are more prone to temperature deviation, take longer to heat up, and are more of a pain to dial in when you're trying a different type of filament. I had more than a 20-degree difference between the heater's reported temperature and the actual extrusion temperature of the filament. Some filaments, like carbon fiber or wood grain filaments, which contain actual wood particles, may require these hardened nozzles, though, as they are higher abrasion and the material will wear out the nozzle way too fast if they're just brass. The nozzle is part of what's called the hot end, which is where the heating and monitoring for the extruder takes place. Most hot ends don't require replacement, but I have had filament jams that were so bad I ended up having to replace them on occasion. Depending on the design of the extruder, this can range from unfortunate to, oh my goodness, I just wrecked my printer. Speaking of new printer time, let's talk about some of the things I would recommend if you're looking to buy a new one. What I have personally found to be the most important is quality control and support. It's tempting to find a cheap brand that seems like it's got all the bells and whistles, but when you get one, which I have in several painful instances, that have problems like faulty temperature probes and noisy fans that stop spinning after 5 minutes of printing, I understand manufacturing and shipping can cause problems, but when it's consistently happening with the same manufacturer, and their solution is to send you an AliExpress link to a stepper motor, it's probably time to find a better manufacturer. I'm not going to name names, but I would say that Creality at least has a huge user base that can help you keep moving forward if you do have problems. I do not think they have fantastic quality control or are anything special on the back end, but are probably far and away the most prolific manufacturer. Another thing I would suggest for a new printer is automatic mesh bed leveling. I want to stress that there is a difference between bed leveling and mesh bed leveling. The purpose of this feature in general is to let the printer know exactly where ground zero is, and it can adjust its height settings so that each layer is placed in the correct position in space. The problem arises, though, that the bed is hardly ever perfectly flat. What mesh leveling does, though, is measure the bed's height at several points and can adapt itself to each change in elevation, not just work from an average. Believe me, the print bed gets more warped than you think. I personally won't buy a printer without at least 25 leveling data points. I generally tell the printer to re-level itself before every print. Changes in temperature, placement, humidity, and storage conditions can all have an effect on the bed shape. In the old days, we used to just bring the nozzle all the way down and turn knobs on the platform until a piece of paper just fit between the bed and the nozzle. This worked, but was a pain, and consequently, you only did it when you thought you had to. I've had several weekends that started out great, then just the changes from one day to the next, as well as a long printing session, ended up with clogged nozzles, failed prints, or worse. Spend the extra bucks and get the printers that can do this for themselves. Another piece of advice I would give to new printers is to avoid the more exotic colors of filament. While it's tempting to get the newest silk, metal, finish, rainbow filament, you might find that the special properties of said spool also make it harder to deal with and adjust for. I try to stick with the same brand of filament, and after ruining a couple printers with the shiny filaments, Now I'm completely content with a solid color PLA or PLA+. So that about covers at least the basics of FDM printers. They have improved quite a bit over the years and made themselves far more approachable to the novice user. I would say, however, that unless you have a good use case or are completely willing to just spend the money for the fun of it, they are impractical for the average user. They can be fiddly, expensive, frustrating, and take a bit of time to learn to use well. If you're designing your own parts and using them for rapid prototyping, great. If you're making specialty parts for your latest project, great. If you're just looking for one because you thought they sound cool, maybe give a thought to how far you want to take your journey. They will suck you in. Be warned. Thanks for watching the video. If you're new to the channel, please consider subscribing and maybe hitting the notification thingy. I'd also appreciate a like, share, comment, or whatever else you'd like to engage in. In the meantime, I hope you enjoy your day.